In the Geometry menu, we will select Stack Geometry. Here we'll specify the overall geometry of the structure. We have three different regions, which are the diameter region, the thickness region, and the corrosion allowance region. At the top of the screen, the elevation of the top of the stack is specified, and this will take into consideration reference elevations specified. You can click the reference elevation button to verify what has been entered, and that screen has been discussed in detail in another video. You have the option to specify diameters in terms of inside diameter or outside diameters. You don't have the option of specifying some as inside and others as outside. They all must be the same. For the overall analysis of the stack, any conical transitions are divided into stepped cylinders. A default value for the number of steps is used unless you check the box to manually specify the number. If you are using pipe for your stack, then you can use the Enter Pipe option to quickly look up the actual outer diameter for a given nominal pipe diameter. You can enter these values manually also. This is just a tool to assist the user. When you click Save, the value is inserted into your diameter entries based upon the elevation that was specified. Next, we have the tables for all of the diameter, thickness, and corrosion allowance inputs. All of these inputs are a cascading input. They start at the top and work our way down the stack. The value remains the same until we enter another elevation, and then it is assumed to be that new value until we add another entry. The one exception to this behavior is when we are specifying a diameter and have a conical transition. We define the diameter at the top of the stack, and then we define the next elevation anywhere there is a change in geometry. If we have a conical transition, then we specify the top elevation of the cone and then the bottom elevation of the cone. You can specify the diameter by entering a value in either column, and the other column will update automatically. If you have an abrupt change from one diameter to another without a conical transition, the software can't handle that situation. You would have to approximate by putting a conical transition that may have a very short height, and just understand that the stress won't be accurate in this region and would need to be verified manually. The software also can have issues when you have a conical transition at the very top or very bottom of the stack. When this situation occurs, for modeling purposes, just place a small section of straight cylinder at the very top or very bottom of the stack, depending upon the situation. This is just needed for modeling purposes. The thickness and corrosion allowance are handled the same way. You specify anywhere those values change, and they are assumed to be that value until another entry is entered. The corrosion allowance is used to calculate the section properties of the stack so that corrosion is considered. The weight of the stack will be based upon the uncorroded thickness and the section properties on the corroded thickness. Once complete, you save the information and then you get a graphical representation of what you have entered. If it doesn't look correct, then you can go back and correct as needed.